Okay, today we're learning about square root functions. The first thing we're going to do is take a look at the parent function, which is f of x is equal to the square root of x. So I'm going to go ahead and fill in some values for our t-chart for that. So I have to find values for x that I can plug into the square root of x. The first value is 0. And if I take the square root of 0, that would give me 0. The next value I'm going to plug in is an x value of 1. The square root of 1 gives me 1. If I go to plug in the square root of 2, that does not come out as a whole number. So I'm not going to pick that x value for my t-chart. Likewise, an x value of 3 does not come out as a whole number. So I'm not going to select that x value either. I am going to pick 4 because we can take the square root of 4 and get a whole number of 2. The next x value that would give me a whole number out for y would be 9. The square root of 9 is 3. Normally, we do list 5 points for nonlinear functions. So I'm going to list the next x value. 16 would be the next x value that I would get a whole number for y out, and that would be 4. Now, notice that my graph off to the right here only goes from -10 to +10 in both x and y direction. So I'm only going to be able to fit 4 points on my graph. Also, guys, if I try to take the square root of a negative number, for instance, the square root of, let's say, -4, this is what we call an imaginary number. We cannot take the square root of a negative and get a real number out. So I'm going to stay away from selecting negative values for x. All right, plotting these points, we have a point at 0, 0. We have a point at 1, 1. We have a point at 4, 2. And our last point that I can fit on the graph is 9, 3. I'm going to connect these points as best I can, and we can see that we are getting a curved graph. It is not a linear function. Okay, we're going to take a look at some transformations. This should sound familiar because of what we've been doing the past couple days with nonlinear functions. So transformations on square root functions work the same as any other function. We take the parent function, which we just looked at, and then we can vertically stretch or shrink by putting a value in front of the square root. Also, this could cause a reflection as well. H in the prompt is going to move the graph either left or right, so it's a horizontal translation. And then K is a vertical translation, so up or down. So when we transform the parent function, we're going to think this H is going to affect the X values. Again, remember the sign that you see is the opposite direction of the way that it would move. And then both the A and the K affect the Y values in the parent function. Okay, so we're going to take a look at an example of a transformed square root function. We had just talked about our parent function and the fact that we were going to pick the values 0, 1, 4, and 9 because those give me whole values, whole number y values. Okay, so there's my parent function. And now we think about this square root function, the square root of x plus 3 minus 2. We have to think about what this would do, both horizontal translation and vertical translation. Notice there's no a value out front, so there's not going to be a shrink or stretch. So this plus 3 that's underneath the square root sign, again, I have to think opposite direction. So that's going to move the graph left 3 units. And then the k value, -2, that's going to move the graph down 2 units. So if I think what's happening to x and y, if the graph is moving left 3, that is going to subtract 3 from the x values. The y value, they are moving down 2. So again, I'm going to subtract 2 from the y values. Okay, so looking at my points here, my x values were 0, 1, 4, and 9. We just said that we're going to subtract 3 from each one of those. So my first x value is 0. If I subtract 3, I get -3. My next x value is 1. If I subtract 3, that's -2. My next x value was 4. If I subtract 3, that gives me 1. And 9 minus 3, that gives me an x value of 6. The y values, we're going to subtract 2 from them. So my first y value is 0. If I subtract 2, that's -2. My next y value is 1 minus 2, gives me -1. 2 minus 2, that gives me a y value of 0. And my last y value of my parent function was 3. If I subtract 2 from that, 3 minus 2 gives me a y value of 1. Okay, we're going to go ahead and plot these points. So my first point is now located at -3, -2. My next point is at -2, -1. 1, 0, and 6, 1. Again, I'm going to connect these points in a smooth curve. And there's my transformed square root function. If I wanted to, I could plot the parent function on this graph as well, guys. If we take a look, 0, 0, 1, 1, 4, 2, and 9, 3. So here was my original parent function. And so if we look, the parent function, the one that's in blue, has been moved left 3 units and down 2 units. And there's my transformed square root function. So here's the next one. We have y equals -2 times the square root of x minus 3 plus 5. We're going to think about what these values do to the parent function. So first of all, if I think about what this -2 does, that is going to be a reflection over the x-axis, and it's also going to be a stretch. So that -2 is going to stretch the graph and reflect. The reflection happens because it's a negative number. The stretch happens because it is a value that is larger than 1. The next value that I see is -3. Remember, this is the opposite sign. So instead of moving left 3, the graph is going to move right 3 units. And then the last number that I see is the +5. That is going to move the graph up. So both the -2 and the 5 are going to affect the y value. I'm going to multiply the y value by -2, and I'm going to add 5. This 3 value, the right 3 units, is going to affect the x value. So I'm going to add 3 to the x value because the graph is going to move to the right. Okay, getting my parent function up here. Again, those points were 0, 1, 4, 9, 0, 1, 2, 3. My x values, we're going to add 3 to them to get the transformed x values. So 0 plus 3, 1 plus 3, 4 plus 3, and 9 plus 3. All right, the y values, we're going to multiply by -2 and then add 5. So 0 times -2 is still 0, plus 5 is 5. 1 times -2, that's -2, plus 5, that gives me +3. The next y value of 2, again, we're multiplying by -2, that gives me -4, plus 5, that's 1. And -2 times 3, that gives me -6, plus 5, that's -1. All right, notice these points, guys, and I should have put them in red instead of blue, but these points here, not all of them are going to fit on my graph. This 12, -1 is going to be a bit too large to fit on my graph now. So I can only plot these top 3. Okay, so if I plot those, 3, 5, it's right there. 4, 3, 7, 1, and then we would also have 12, -1, but again, that's not fitting on my graph. It's somewhere here. All right, so if we connect these points, that is what my transformed square root function is going to look like. Notice that the graph has flipped over the x-axis. It's stretched in the vertical direction. It's again shifted right and then up. Guys, the next example that we have is a U-try. So what I would like you to do is pause the video here, go ahead and see if you can graph this transformed square root function, and then when you're ready, unpause the video to see the solution. Okay, hopefully you took some time to graph this on your own, guys. Thinking about my transformed function here, there is going to be a stretch vertically, a shift right 3 units, and a shift up 2 units. So the x value, I'm going to add 3 since it's going right 3. The y value is being stretched by a factor of 4, and it's being shifted up 2 units. So I'm going to take the y value, multiply by 4, and add 2. The new x values are 3, 4, 7, and 12. Again, I just took these x values on the parent function and I added 3 to them. Okay, next we're taking the y values, we're multiplying them by 4, and we are adding 2. So the first one, 4 times 0 is 0, plus 2 gives me 2. 4 times 1 is 4, plus 2 gives me 6. 4 times 2 is 8, plus 2, that gives me 10. And 4 times 3 is 12, plus 2 is 14. Looking at these points, again, my last point is just a hair too big to fit on the graph. So if we just plot those first 3 points. My first point is 3, 2. The next one is 4, 6. And the last one that fits on the graph nicely is 7, 10. You can connect these 3 points in that smooth curve graph. And there is my transformed square root function. This concludes the notes for today, guys.